In this video, we're taking a look at how to find the general solution and hence how to find the solutions to a trigonometric equation. So the first thing you need to think of when you see the question asking you for general solutions or finding all of the solutions is you need to immediately go to your cast circle. So the cast circle is just going to allow us to make sure we're finding all of the angles when we might have a negative ratio or a positive ratio, because if you put it into your calculator, it will only ever give you one answer, but we know that there's at least two depending on what your limit is in the question. In the question then we have been asked to find the general solutions that satisfy the equation 2 cos of 3 theta is equal to minus 1. The first thing I would do here is I would get rid of that 2, and I'm going to do that by dividing both sides by 2. So then I get 3 theta is equal to minus 1 over 2. In this scenario then, I know that I have a negative cos, and where do I get negative cos ratios? That is in the sine and the tan. Here then, what I am going to do is I'm going to find a reference angle. So I'm going to ignore the minus part, and I'm going to just call this A. So I'm going to find cos of A is equal to, the minus is just directional, the half is the part that I'm interested in. And if I get that reference angle in radians, because they want me to go from 0 to 2 pi radians, I'm going to have that A is equal to cos inverse of a half. And if we do that and we get it in our radians, we get pi over 3 radians. So that's only the reference angle. I want to find not that angle, but if I went the whole way around into that quadrant. So I start here and I rotate around. That angle there is the 3 theta. And that 3 theta is going to be almost at this line here, which is pi, but we stop short of it by pi over 3. So what I get there is that 3 theta is equal to 2 pi over 3. Now they have asked in this question for the general solution, and if we're talking about the general solution, then there's actually several things going on. I could have this point here and I could do right the way around by 2 pi. I could add on 2 pi to that and I would still be in the same quadrant and it would still give me the same trigonometric ratio. If I do another 2 pi, so if I was here and I go around again and I do another 2 pi, I'm still in the same quadrant, so it's going to still be negative and it'll still give me the same ratio. So I could just continuously add 2 pi to this and still get the same answer. So that's where the general solution is coming from. So I want to say add 2 pi just continuously. And how I'm going to say that is I'm going to say plus 2 pi n. Now, that is the general solution for 3 theta. I would like to get it for theta. So I'm going to divide both sides by 3, and that brings me to 2 pi over 9 plus 2 pi n over 3. And we can leave it like that, or we could try and combine them. If I multiply the bottom by 3 here and I multiply the top by 3, I'm going to get theta is equal to 2 pi plus 6 pi n all over 9. Just to write it as one fraction, you don't have to do it. That was enough at that stage. That's the general solution for theta when it's in this quadrant. If it's in the other quadrant, I've gone past my pi. So in that scenario then, I'm going to have that 3 theta is equal to pi plus pi over 3. And if I do that, I get 3 theta is equal to 4 pi over 3. And then remember, I could keep doing circles. I could keep circling around and around again and around again, and I could keep adding 2 pi radians to that, and I would continue to end up in the same position. So I can say plus 2 pi n, and then I'm going to have that theta is equal to 4 pi plus 6 pi n, and that's all over 9. So I've got two possibilities, or two kind of formula here for calculating what theta might be depending on the n's. So I'm going to then have, in this scenario, let's try n is equal to 1. In each of these scenarios, well, actually we'll go slower, we'll go to n is equal to 0. Let's go to n is equal to 0 first. In this kind of little function that we have, we're going to have theta is equal to 2 pi over 9, because this part, 6 pi n, works out to be 0. I'll also have, from this guy over here, 4 pi over 9, because the 6 pi n over there also works out to be 0. So that's if n is equal to 0. The next thing I'm going to do is n is equal to 1. And if n is equal to 1, then I'm going to have theta is equal to 2 pi. So I'm going to have 2 pi plus 6 pi, and that's all over 9. So I'm going to get 8 pi over 9. And I'm also going to have over here 4 pi plus 6 pi, which is going to be 10 pi over 9. So 10 pi over 9. I can go again because I have not yet exceeded 2 pi, right? So those are that's less than 1, and this one is just over 1. So I want to keep going. I'm going to do 2 for n is equal to 2, and then I'm going to have that theta is equal to 2 pi plus 12 pi. That brings me to 14 pi over 9. So we still have not exceeded our 2 pi. So that's 14 pi over 9. So that one is okay. If I do it to this one, I'm going to have 4 pi. So 4 pi plus 12 pi, because it's 6 by 2. And then I'm going to have 16 pi over 9. And that still doesn't exceed 2 pi, because 2 pi would be 18 pi over 9. So we're still not at the kind of threshold yet. So I'm going to do n is equal to 3. And I'm going to see what I get when I do that. So I'm going to do 2 pi in my calculator plus 6 by 3 pi. And then that is 20 pi over 9. There is where we reach our limit. So it cannot be 20 pi over 9. So we can't include that one. So we can stop here at this one, because we know if that's over the limit, then this one is certainly over the limit too. So our solutions are theta is equal to 2 pi over 9, 4 pi over 9, 8 pi over 9, 10 pi over 9, 14 pi over 9, and 16 pi over 9. And again, we do not include 20 pi over 9, or we don't even need to sub it into this one, because we know that it's above the 2 pi, which was given as the limit in the question.